The last topic in this note packet is area of a triangle. So let's start off by reviewing the basic formula for the area of a triangle. The area A of a triangle is given by 1/2 times the base times the height. Okay, this is nothing more than the basic formula you learned in a high school geometry class. Okay, 1/2 times the base times the height. So B stands for the base of the triangle, H is the height of the triangle. Okay, height is sometimes called altitude. Okay, notice here we're using a fancy A for area. Okay, the reason is we need a way of distinguishing A for area from the A that's used for angles. So like when I have a triangle and the vertices are A, B, and C, and I'm talking about angle A, we don't want to mix the two A's up. So when we're talking about area, you're going to see the fancy A for area in your textbook as well as MyLab Math. Okay. All right, so we know this basic formula for area, but if you read here in the second bullet point, it says that oftentimes the information required to use this formula is not given or it's difficult to calculate. Okay, so usually when we use this formula 1/2 times the base times the height, we can get the base of the triangle really easily. It's the height that gives us a problem. It might be extremely difficult to calculate the height of the triangle. So there are special area formulas that exist for both the SAS and side triangles. So if you've got a side angle side, or if you're dealing with a triangle from the side case, there are special formulas for those two cases only that will help you easily compute the areas of those types of triangles. Okay, so let's start off with side angle side. Okay, so what you'll see here, I have a triangle here, and I'm going to show you where the formulas come from. If you look underneath here in the box, these are 3 different formulas. They're all equivalent. It's just depending on what sides and what angle of the triangle you're talking about. But these are the formulas that you can use to find the area of a side angle side triangle. Okay, so let's see where these formulas come from. So in a side angle side triangle, first of all, I'm going to draw on here. I'm going to put the vertices. So let's say this is angle A, this is angle B, and this is angle C. Okay, it doesn't matter which vertex is which, I just labeled them randomly. Okay, so again, with our naming convention, if we go straight across from angle A, this is going to be side A. If we go across from angle C, this is going to be side length C. If we go across from B, this is going to be side length B. Okay, so in a side angle side triangle, we are given a side and then the angle next to it and then the side next to that. Okay, so let me label this. Let's say we are given this side, this angle, and this side. Okay, so that's our SAS. Okay, so now we need to figure out, okay, well, how would I compute the area of this triangle? Okay, and this is all the information we have to go on. Okay, well, we know the area is 1/2 times the base times the height. Okay, when we look at this triangle, we immediately know the length of the base. Okay, the base is going to be side length B here. Okay, whatever that length is, that is the base. Okay, the height is going to be a little more difficult to get. Okay, so let's talk about that. So what is the height of the triangle? Well, it is this green length that I'm drawing in. Okay, so this, if I go from the very tip top down to the base, okay, and I'm forming a right triangle here, okay, this green distance is going to be the height of the triangle here, okay? All right, so I'm going to call this green distance H because that's the height of the triangle. And then what I can do is I can use right triangle trigonometry. Okay, when I drew this height in, it split the major triangle into 2 smaller triangles that are both right triangles. Okay, so if I focus on this right triangle right here, this yellow one, okay, what can I write down? Okay, well, I can say, hey, if I look at angle A here, I know the side opposite it, that's the height, and then I know the side across from the right angle, this side, that's the hypotenuse. So I can say, based on the yellow triangle, that the sine of angle A is equal to h over the length of the hypotenuse for this yellow triangle, that is C. Okay, h is the height. So now I have a way of solving for it. Okay, so let me rewrite this. Sine of A is equal to the height over length C here. If I want to solve for h, I can do that by multiplying by C on this side, because I'll have a C in the top and a C in the bottom, and they will cancel. If I multiply by C on the right, I have to do it to the left side. So this is ultimately going to tell me that the height is the same thing as C times the sine of A. Okay, so this is how I'm going to get my height. It's C times the sine of angle A. So now we know the base, we know the height. We can plug it into our usual formula, 1/2 times the base times the height. This is going to give us 1/2 times the base. The base is length B in the picture, and then we're multiplying it by the height. The height is the same thing as C times the sine of angle A. Okay, so if you come down here, you're going to notice that what we came up with here, that the area is 1/2 times B times C times the sine of angle A. That's this formula in the middle. Okay, the other two are derived similarly. Okay, we came up with this formula because we concentrated on this right triangle that involved angle A, but you could redo what I just did and use this triangle over here. Okay, and then this would produce the here you would be focusing on angle C. Okay, so this would produce, well, this would produce this formula down here, the one with C, that would produce this formula. Okay, so there are 3 different formulas because there are 3 different angles. Okay, so the process we went through with the yellow triangle produced this equation in the middle, but like I said, if you repeated the process, we did ours with angle A, but if you repeated the process for angle A, or sorry, for angle C or angle B, you could come up with these 2 other formulas. Okay, so let's read what's in the box here. It says for the area of a side angle side triangle, the area A of a side angle side triangle equals 1/2 the product of 2 of its sides times the sine of their included angle. Okay, so to make sense of the wording there, let's focus on the equation that we derived, where we came up with the area is 1/2 times B times C times the sine of A. So when we go back to our picture, remember what we were given for SAS. We were given side length C, we were given angle A, and then we were given side length B. Okay, so this is saying that to get the area of this triangle, you take 1/2 and you multiply together the 2 sides you were given, and then you multiply by that the sine of the angle you were given. Notice that the angle you were given is the angle included between the 2 sides that you were given. Okay, so that's what this verbal description is saying. The area of a SAS triangle is nothing more than 1/2 times the product of the 2 sides that were given times the sine of the given angle, which is the angle included between the 2 sides that were given. Okay, the other shortcut, this was the shortcut for an area of a SAS triangle. The other shortcut is for the area of a side-side-side triangle. Okay, and clearly that is the case when all 3 sides are given. Okay, I'm not going to derive this formula. It is called Heron's formula. So this is what it says. The area A of a triangle with sides A, B, and C is given by this formula. The area is equal to the square root of the following quantity: S times S minus A times S minus B times S minus C. S is 1/2 times A plus B plus C. It's called the semi-perimeter of the triangle, okay? So when you look at this quantity, okay, or when you look at this formula, okay, you will be given side lengths A, B, and C. You have all three sides of the triangle. From those lengths, you need to compute something called the semi-perimeter, okay? The semi-perimeter is basically half the perimeter of the triangle, okay? Because look at the formula. To get this S value, you have to add up all the sides of the triangle, so that's the perimeter, and then you divide it by 2. Okay, so I'm going to write here S is half the perimeter of the triangle. Okay, so that's how you're going to get the semi-perimeter, and then once you have it, you just pop it into Heron's formula, and that will give you the area of your side triangle. Okay, so in the next two examples, we're going to try out Heron's formula, and we're also going to try the shortcut for computing the area of a SAS triangle.